Hi, welcome to a complete course in calculus. This is the Tedesse. So in this video, we'll specifically see some examples of integration, specifically how to apply the fundamental theorem of calculus, the first fundamental theorem of calculus and the second fundamental theorem of calculus, as well as how to find area under a curve. So the first example says, find the definite integral of absolute value of x squared minus 6x plus 5 from 0 to 10. Now the first question is the fundamental theorem of calculus says if you have integral from a to b small f of x dx, if you are trying to find the definite integral, which is nothing but the limit of the Riemann sum as n goes to infinity, this is just a symbol, okay? This is a symbol. So that integral, it can be evaluated just by finding the antiderivative. It says just find the antiderivative of small f, which I call it capital F, and then you evaluate from a to b. This is notation, okay, which stands for what? F at b minus f at a. That's what we basically need to do. But the problem here is, how do I find the antiderivative of an absolute value? There's no way to do that. So what I have to do is I'll be using what is called the additive property. What is the additive property? The additive property says, let's say you have from a to b, the integral from a to b, f of x dx. Now, if you pick any point c between a and b, then this guy can be written as a to c f of x dx plus c to b f of x dx. This is called the additive property. If you have another one, d here, you can do a to c, c to d, d to b, whatever partition you want, okay? So basically it means from going a to b means going a to c, c to d, d to b. That's what exactly we'll be doing, okay? So why I'm gonna use that? Because I know that I can solve this absolute value quadratic expression. I have to, find where that guy would be positive or negative, okay? So let's do that first. So I have x squared minus 6x plus 5. Oh, this can be factored as what? X minus 5, x minus 1. Very good. So let's see the sign. I have x equal to 1, I have x equal to 5. So if you give me a number to the left of 1, actually we are looking only from 0 to 10. I don't really care about the others, right? So if I pick a number between 0 and 1, let's say half, right? So half minus 5, it's negative. Half minus 1, it's negative. Negative times negative is what? Positive. So if you pick a number here, let's say 2, 2 minus 5 is negative. 2 minus 1 is positive, so it will be negative. If I pick a number here, 6, 6 minus 5, 6 minus 1, both of them are positive. So you see now, I know what happens to this guy, this quadratic expression in each interval. So what that means, the integral from 0 to 10 absolute value of x squared minus 6x plus 5 dx can be written as what? The integral from 0 to 1 absolute value of x squared minus 6x plus 5 dx. I'm using the additive property plus 1 to 5 the absolute value of x squared minus 6x plus 5 dx plus 5 to 10 the absolute value of x squared minus 6x plus 5 dx. I'm just using the additive property. Now I'm going to use my sign chart here. Oh, what happens between 0 and 1? The expression is positive. If it is positive, I don't really need the absolute value. That's what I'm gonna do, okay? Oh, okay, it's positive there, then I'll just remove it. X squared minus 6x plus 5 dx. How about between 1 and 5? Oh, between 1 and 5, it's negative. So if this guy is negative, because it's in absolute value, right? I know that it's negative, but it's an absolute value. So it has to be positive, right? To make it positive, I need to multiply it by a minus sign. Hope this is clear. Why I'm multiplying by negative sign? Because it's in absolute value. And for sure, we know it's negative. Negative times negative is positive. Plus 5 to 10. Now between 5 and 10, it says it's positive, so I don't really need the absolute value. It will be x squared minus 6x plus 5 dx. That's it. Now I need to find the antiderivative of, or I can use the fundamental theorem of calculus in each case. Okay, so let me show you at least the first part, and then you can do the remaining. So what is the antiderivative of x squared? It's x cubed over 3 minus 6. What is the antiderivative of x? X squared over 2 plus the antiderivative of 5 is 5x from 0 to 1 plus, I have a minus sign there. Okay, don't forget the minus 9. So I'll just copy the same thing, minus 6 times x squared over 2 plus 5x. But now in this case, it's 1 to 5. Okay, plus the next one is again the same thing, x cubed over 3 minus 6 times x squared over 2 plus 5x from 5 to 10. So the remaining thing is you just need to evaluate at 1 minus at 0. You evaluate at 5 minus at 1. You evaluate at 10 minus at 5. So basically this is just evaluating. I don't think it's necessary. So just check your answer. You should come up with 314 over 3. That should be the definite integral. Okay. So let's go to the next example. The next example says, find the area of the region bounded by the graph of e to the x. This is what the graph of e to the x is. The vertical line x equal to 0, the vertical line x equal to 8, and y equal to 0. So basically we are trying to find the area of this shaded region. Because e to the x is continuous and non-negative, it's above the x-axis, area is nothing but the definite integral from 0 to 8 e to the x dx. So again, the fundamental theorem of calculus, the antiderivative of e to the x is e to the x, 0 to 8, which is e to the 8 minus e to the 0, which is e to the 8 minus 1. That should be the area under the curve. Okay, let's go to the next example. So the next example says, for the function f of x equal to x to the 7 on the interval 0 to 7, check if mean value theorem for integral is applicable. If so, find the number c guaranteed by the mean value theorem for integral. Okay, so what is the mean value theorem for integral? It says if you have a continuous function on a closed interval, then there is a number c such that the integral from a to b f of x dx will be equal to what? The value of the function at c times b minus a. And by the way, this f at c, what we call it, the average value. Okay, we'll see that in the next example. All right, so let's do that now. A is 0 to 7, f of x is x to the 7 equal to, dx equal to f at c. F at x is x to the 7, so this would be c to the 7 minus 0. Okay, so what is the antiderivative of x to the 7? X to the 8 over 8 from 0 to 7 equal to 7 minus 0 is 7 c to the 7. Okay, so that gives me what? 7 to the power of 8 over 8 minus, at 0 it is 0, 7c to the 7. So 7 to the power of 8 divided by 8 equal to 7c to the 7. Now if I divide both sides by 7, so that gives me what? 7 to the 7 over 8 equal to c to the 7. So how do you find c? C is nothing but the 7th root of 7 to the power of 7 over 8. Now, this is 7th root of 7 to the 7 over the 7th root of 8. So what is the 7th root of 7 to the 7? It's 7, right? Divided by the 7th root of 8. That is the value of C guaranteed by mean value theorem. Yes, it exists because it's continuous on the closed interval. Okay. Let's see the next example. As I said, I'm going to show you the average value. So the next example says, find the average value of f of x equal to 6 e to the x on the interval negative 3, 3. And then find the c or the x, it doesn't matter where, the value of the function equal to the average value. Okay. So again, from mean value theorem, I told you that a to b f of x dx equal to f at c times b minus a. This f of c, so if you divide both sides by b minus a, you will have f of c, which is equal to 1 over b minus a to b. Basically what I'm doing is I'm dividing both sides by b minus a. Don't be confused because I have here 1 over. This is the same as just like writing this over b minus a, okay? No difference. So this is what we call it the average value, okay? So f at c equal to 1 over b is 3 minus 3, negative 3 to 3, 6 e to the x dx. So this is what we call it the average value, 1 over 6. What is the integral? So I have 6. What is the antiderivative of e to the x? It's e to the x, negative 3 to 3. This cancels out. So that gives me e to the 3 minus e to the negative 3. That is what we call it the average value, okay? That is what the average value. Now, it says, what must be the value of x or c where the function equal to the average value? Oh, so which means I have to solve f of x or f of c, doesn't matter, okay? F of c equal to e to the 3 minus e to the negative 3. But what is f of x? 6 e to the x equal to e to the 3 minus e to the negative 3. You divide both sides by 6. So e to the x equal to e to the 3 minus e to the negative 3 over 6. Now this is exponential function. This is just a number, okay? E to the x equal to that. Let's take natural log of both sides. That gives me this guy, ln e to the x is x equal to ln of e to the 3 minus e to the negative 3 over 6. That is the value of x where the function will be equal to the average value. All right, the last example for this video will be, we want to find the derivative of an integral. So it says, let f of x equal to 0 to sine x for square root of t dt. So we want to find the derivative. So finding the derivative means what? It's nothing but finding the derivative of this integral, right? 0 to sine x for square root of t dt. So that's what exactly we are trying to do. So I have two methods to do this, right? I can do it in two ways. Method one. So the first method is I can directly use the fundamental theorem of calculus, directly apply the fundamental theorem of calculus. So what does that mean? Oh, I have to find the antiderivative of 4 root t, and then I'll evaluate the upper limit minus the lower limit, and then I'll find the derivative, just like the usual derivative. So let's do that. So f of x, which is equal to 0 to sine x for square root of t dt. So this is equal to, what is the antiderivative of 4 root t? Oh, root t means t to the half. If you add 1, it will be 3 half, okay? From 0 to sine x. So if you simplify this 3 over to flip, it will be 1/3 square root of t cube, right? From 0 to sine x. 8 over 3. What is the value at sine x? It will be square root of sine x cube. Okay, that is what f of x is. Now let's find the derivative. So what is the derivative? The derivative becomes what? Oh, 8 over 3 is a constant. What is the derivative of this guy? It will be 3 times square root of sine x square, right? Times the derivative of the radical. The derivative of the radical will be what? Half, right? Half sine x to the power of half minus 1, negative half, times the derivative of the inside, which is cos x. So be careful here. I have 3 functions. The outer is x cubed, the inner is radical, then I have another one which is sine of x. Okay, so that will leave me, the 3 cancels out. Radical sine x square means it's sine x, right? So it will be 8 sine x. I have cos x here. And then I have sine x to the power of negative half. Negative half means it goes down. So it will be 2 radical sine x, okay? Now, it's up to you. If you want to simplify, this is 2 by 2, this is 4. So I have 4 sine x cos x divided by radical sine x. Again, I have sine x, I have radical sine x here. Really, you can, multiply by, this is what we call rationalizing, right? Radical sine x. So this gives you 4 sine x cos x radical sine x divided by sine x, right? So the sine x cancels out, so that should be the answer. 4 cos x radical sine x. That is what the first technique. Basically, what I did in this case is, let me just refresh you what I did. What I did is, hey, I have 4 radicality. I have to find the antiderivative and then evaluate at sine x and 0. So then the rest is, finding derivative here, which I'm using chain rule. So what is method 2? Method 2 says, if you are trying to find d by dx of, a to any function g of x, f of t dt, okay, something like that. If you want to find the derivative, it should be f evaluated as g of x. It should be very straightforward, times g derivative. This is what we call it, the second fundamental theorem of calculus, the second fundamental theorem, okay? So if you are using method 2, so this should be, hey, you are trying to find d by dx of 0 to sine x square root of 4 times square root of t dt. So this will be f, which is this guy, evaluated as g of x, evaluated as this, right? So your f of t is 4 radical t. So f at g of x is sine x, right? It will be 4 radical sine x. So that will give me 4 radical sine x times the derivative of g. What is the derivative of sine x? Cos x. That's what exactly we have here, right? All right. Thank you very much for watching. I'll see you in the next video.